Okay, we're going to get started. We have a very full program, and I'm so grateful for our webinar today, which is a fascinating one. It's going to help us learn what you can and can't do with AI tools like ChatGPT, Claude, Gemini, DeepSeek, and Perplexity. We have very esteemed scholars with us. I'm Beth Daly. I'm the executive editor and general manager of The Conversation. And most of you know us, but for those who don't, we're kind of a unique journalism national news outlet. We're a nonprofit, and we really rely on the experts in academia who really know what they talk about to write for us. But because many academics often write for more academic journals than the general public, we have a team of over 20 editors, very subject specific, who work with them to make the writing in plain language. All our content goes out on the AP Newswire, goes to about 1,000 news outlets every month or so, and in read across the country, from everything from the Washington Post to the tiny Kitsap Sun in Washington State. So a couple of quick opening remarks, and we'll launch right in. First, thanks a great deal to the Patrick J. McGovern Foundation, who's helping support this webinar, as well as supporters like you. We're a nonprofit newsroom, and we rely on our readers to support our work and keep the lights on and everything humming. So thank you to everyone who does support. And even if you can't support, thank you for reading. A couple of housekeeping matters. You please don't raise your hand. If you have a question, put it in the Q&A. Everyone is muted. And the only way you can be heard or have a question, I know many people have questions, is to please put it in the Q&A, and we'll try to get to as many questions as possible. The chat is not working as well for the general public. So again, Q&A is the way to go if you have a question. So without further ado, oh, I did want to thing. We have an AI newsletter you might be interested in. We just started very recently. We already have about 9,000 people as members, and we'll put in the chat if you care to learn more about it, kind of cutting edge AI work. So without further ado, let me introduce Eric Smalley. Eric has over 30 years of experience as a science and technology reporter and editor. His work has appeared in the Boston Globe, CNET, Discover, Nature, Science, Scientific American, and Wired, to name a few. He co-founded and edited Technology Research News, a weekly online news publication that covered university research in emerging technology and applied science. He's a graduate of Oberlin College, and what's more, he's an amazing musician too, although you may not learn about that at this session. So without further ado, Eric, I'll hand it over to you, and I'm going to disappear until the end.
Thanks, Beth. Hi, everyone. Thanks for joining us. So AI is everywhere, and I mean that in three senses. First, you'd be hard-pressed to watch a news program or scroll through a news website without encountering the term AI. Second, AI has permeated pretty much every facet of life, work, education, politics, healthcare. And third, AI is embedded in many of the devices and software we use and in the systems underlying the services we use, often out of sight and out of mind. Today, we're going to look at a form of AI that people consciously and deliberately use, large language models. These are the AI systems, deep learning neural networks that are under the hood of ChatGPT, Claude, DeepSeek, Gemini, Meta AI, and a growing list of other AI chatbots and assistants. I'm pleased to introduce two scholars who are going to help us dig into what these things are, how they work, what they're good for, and what maybe you shouldn't try to use them for. Going in last name alphabetical order, Mayank Kejriwal is a research assistant professor in the Department of Industrial Systems and Engineering at the University of Southern California, and a principal scientist at USC's Information Sciences Institute, where he leads the Artificial Intelligence and Complex Systems Group. His research focuses on designing and applying AI to real-world complex problems. Mayank has written numerous articles for The Conversation, including about why AIs have trouble handling the unexpected, why they lack common sense, and why they aren't good at making rational decisions, and how researchers are working on overcoming those issues. Wang is an associate professor of computer science and engineering at the University of Michigan, Her research is focused on natural language processing, computational social science, and machine learning. Lu aims to build trustworthy language models that produce factual, accurate, and safe content, and she has created applications to understand narratives and media bias and support education. Lu recently wrote an article for The Conversation about a method for helping AIs to get their facts straight. So Mayank, I'll start with you. In simple terms, what are large language models? What makes it possible for a piece of software to engage in convincing, often helpful, and sometimes unnerving conversations with people?
Yes. So a large language model or an LLM, uh, is basically a type of artificial intelligence, more specifically a deep neural network that is trained to model and generate human language. And I use the word model because as you pointed out, the LLM can be very unnerving in the way that it communicates. It makes mistakes unexpectedly at times, but it does seem to have a very good grasp of how we communicate, what the next word is in a sentence, and that's basically what it does. It is learning to predict what the next word in a sentence is. So think about autocomplete on steroids. And the reason why they are so good is that they are large, so they are trained on massive amounts of text from books, websites, even code, more recently music, images, you name it, the sum total of human output. And they use billions or trillions of parameters. So think of parameters like little tiny switches in a room where the room is a large language model. And by figuring out the right combinations of these switches through all of this data that it's reading, it's able to model human language, pretty precisely, and hence it's able to predict the next word in a sentence and have those conversations with you that sound very realistic.
Okay. And Lou, what are these good for? I mean, what are people tending to use them for? What do you recommend to people to use them for? And what do you yourself use them for beyond studying them?
Yeah, so we have seen a lot of, successful applications of those large language model, in particular in terms of writing. For example, I have seen a lot of surveys showing that people use them for writing articles, drafting emails. We also have seen startups who are using them to creating or summarizing those meeting notes. I have seen education applications where students use them to learn new knowledge, build a tutoring system out of those. And the researchers have also used them to do scientific study. And otherwise, we can also use them to do translation and probably even learn new language we don't speak.
So staying with you, Lou, today there are many of these models on the market, and the big AI companies, some of them have more than one. OpenAI just announced GPT 4.1. There seems to be different flavors of these. So tell us, what are multimodal models? What are mini models? What are distilled models? And would I use them for different things?
Yeah, those are great questions. So when we talk about large language model, they're purely text-based. And then when we talk about the multimodal model, it means that they can handle more than text in both input and output, such as like text, image, audio, video. So with those kind of capabilities in mind, we're able to build new applications. Let's say we can do visual question answering. We can build more interactive agents out of those model. So those are multimodal model. And when we talk about these two model, we're focusing on the intention of why we want to have them. For one is that we want to build a smaller version from their larger, stronger counterparts, meaning that they have a smaller size, they're more efficient, but they should keep, at least a comparable performance from their larger versions. So this is more for efficiency, purpose. And this also touch on the mini or smaller models you were just talking about. The goal of having those models is because I want to just use them for, platforms with low compute resource, or for the purpose of like, I want to have, I have some privacy concern, right? I don't want to send those data for larger models, training them. So those are why we want to have those.
Okay. Mayank, tell us a little more about how these work in terms of training, the training data. What is that data? You mentioned it's massive amounts of it. What what is the data that most of these models tend to be trained on? And then what is reinforcement learning?
Yeah, so concerning the training data, when it comes to the commercial language models, like the ones that you see from Google and OpenAI's ChatGPT and Anthropic's Claude and so on, the truth is we don't know exactly what training data they are using, and this is also a contentious issue because some of these platforms may be using copyrighted data. So this is something that is being litigated right now. However, we do know that a lot of the open data on the internet, ranging from Wikipedia, which has always been popular in the natural language processing community for training a lot of these models, to just in general scraped data from the web, GitHub repositories where people publish code, and so on. All of these are fair game, and we know are being used for training the language models. So that is the first question. And the second one, reinforcement learning. I think a lot of people in the audience have probably heard the stories about AlphaZero and the AI that beat the grandmaster on Go and chess, and also won the Nobel Prize for chemistry, the people who worked on that for predicting protein structures and so on. So that is where reinforcement learning was historically applied, which is in domains like game playing, where you have a player, the player is interacting with an environment, is getting signals from the environment, and is then modifying, is getting reinforced. You receive a positive signal, you win a game, you lose a game, you gain points. And so based on that, you modify your strategy, right, to respond. What is very fascinating is that the same paradigm was applied to language and proved to be very successful, and the first product that we really saw was ChatGPT, the first real large-scale product that came out. And the reason why they did that, why they were able to achieve that success, was really because they applied reinforcement learning in a very powerful way to the modeling of language. And since then, we have seen massive progress since in the sequence of models that have come out since then.
And what does it mean to fine-tune a model?
Yeah, so fine-tuning a model basically means that it's exactly what it sounds like. You are training the model to accomplish something very specific. So without fine-tuning, the model is very generalist. So it understands and sort of models language. It can respond to general queries. But let's say if you wanted to give you legal responses, or you wanted to be an expert on anti-money laundering, right? Or a healthcare expert. Typically, if you fine-tune the model using your own data set, then you receive responses that are much more specific, much more customized. And it's like that extra layer of training on top of what the model can already accomplish. So it's very good for domain-specific applications and for private applications where you don't want the data to be public, but you want the data to be used for customizing the model.
Okay. Staying with you, Mayank, but Lou, jump in if you want. Language models seem to be expanding in a couple of ways. One is reasoning. And what does that mean to have a language model that has reasoning abilities? And there are actual models that are called reasoning models. This sounds like they're getting more human-like in a sense, but I don't necessarily think that's exactly what this refers to. So what does it mean for one of these models to have reasoning ability?
Yeah, let me illustrate through a very simple example. So, if I ask the question that, Barack Obama is taller than George Bush, or something like that, right? Like that does not require reasoning, because we need to look at the heights of both individuals. One is taller than the other or not, right? And so we can answer the question by looking up facts, or I can ask, what is the height of X, or what's the capital of Y? And so those are factual questions. They don't involve reasoning. A reasoning question would be something like, if X is taller than Y and Y is taller than Z, then is X taller than Z? Right? Now, I don't need to know the heights. I don't need to know who X and Y are, but I can apply reasoning to figure out that X is taller than Z. if the premise is true, right? So in very simple terms, reasoning is when you're given a premise, and from the premise and available facts, you can infer new facts. And we are very good at that because we have common sense reasoning. We are also taught certain kinds of academic reasoning. You see this in SAT exams and so on, where they test your reasoning. Now, what is interesting is that large language models have been shown to be capable of reasoning, and increasingly so. They do fail in a number of instances, but they have gotten very good at it. And the reason why that is important is that it shows that they are not just memorizing, because if they were not capable of that, you might have said, well, it's a glorified search engine, right? It's processing a lot of data on the internet, and then it's just regurgitating in some other way when you're asking a question. But what we have found is that they are capable of inferring original, making original inferences, based on a given set of facts. And this is really powerful because it opens them up for a whole range of applications, like writing code, for example, or just the number of applications that you mentioned. All of those would not be possible without some kind of reasoning.
So Lou, tell me a little more about that in terms of what as these gain more reasoning ability, or if you're choosing between a regular model and a reasoning model, what would the use cases be? Why would I want to use one or the other, and what new capabilities might these give us?
Yeah, absolutely. So for the reasoning models, they are pretty powerful in terms of like solving more complex problems. So in particular, one phenomenon we have observed is that they're able to do human-like multi-step thinking, or you hear the word like chains of thoughts, right? So it's kind of like how human would solve something more complicated by knowing or learning or using that knowledge we know, and plus the logics and the rules, and then to solve them in a structured way, like we learn in, say, in deduction or induction. So this is probably good for solving something that, more complicated or open-ended in some sense. And so those models, they are trained to go beyond just do word prediction, like Mayank just said, right? And they're actually being able to do more about situational awareness, like knowing what is going on and knowing how am I supposed to break this more complicated problem down into, sub-problems and solve them in which order. So this is something particularly useful of those model. And we have seen people use them to solving, more complicated math problems. In particular, there are some progress made for solving more open, math problem. We have seen them used for, coding, which is like kind of like our job, which means that we need to write a lot of code, and they're able to help us to create, large repository, help software engineers to make more progress, finding bugs in it. I have seen people who are using them for, brainstorm scientific, ideas, actually including implement them and also producing a proper paper out of that. You probably have heard of like a recent progress where a startup find that the paper produced by an AI model is able to pass a workshop level reviewing process. So that is considered definitely a significant progress.
Okay, I just want to pause for a second to remind everyone that if you have questions, please put them in the Q&A. Thanks. So Lou, I was mentioning that these models are gaining abilities kind of beyond their core functions. Another one is the ability to use other tools or other software, go out to the internet, access external data, access other pieces of software. Tell us a little bit about that. Where are we with that, and how does that make things useful?
Yeah. So those models, they are originally pre-trained to do word prediction. We talk a lot about it. And this kind of limiting themselves as being very passive, right? So I'm given a prompt, I'm going to answer them by generating a bunch of words. So in order to make them to be more active, so we need to allow them to be able to do more than that, meaning make actions in the real world. So for example, one is that accessing information on the internet. because those models are trained on static knowledge and then what's going on now, they probably has no knowledge of that, right? So in order them to make, better reasoning, they can, access information retrieval tools to access those up-to-date information. They can also access probably like, say, calculators so they can do math better, right? Or they can access API to help me to book a flight or a hotel. So those are the ways and the potential directions to make them more useful in our daily life.
Are any of the main models doing that now? Like thinking of ChatGPT and Claude and all that. Do any of them do that now?
Oh yeah, absolutely. I think all of those frontier models developed by the leading companies, they have this, capability to be more agentic, meaning that they have this agency to perform actions on, our behalf. So I think they have made a lot of progress building connections. Actually, there is more recent progress, I think, from Claude. They have a protocol called like MCP, actually exactly about how you can, build a standard to connecting those models with external APIs and applications in a, safe, reliable way.
Okay. And Mayank, Lou mentioned agents. That's one of the buzz terms these days, or the newer ones is AI agents. What are they and what sets them apart from regular chatbots? And why would I want to use an AI agent versus a AI chatbot?
Yeah, it's a great question. I think there are three dimensions that distinguishes agents from generic use of chatbots, and you mentioned one of them, which is the use of tools slash APIs, right? So these APIs, we can just generally think of them as tools, and they are all over the internet. When you book a flight, etc., you're basically using an API or a tool, right, to make the reservation or even to get information. So I think the use of tools is one. The other one is a memory. So the very early chatbots, the first version of ChatGPT that came out, etc., they were really memory less. Like every time you would begin a chat, they would not take into account, the previous chats, or it would just be difficult to get them to focus on a long form conversation. But now they have very strong memories, and it's even getting better, so they can pick back up where they left off even in a very long conversation. And this is important because many complex problems are long form. They are not really short form. You can't express them in just one or two sentences, but it can be a back and forth, right? Like you asked me to book a flight, but then something goes wrong. So there's something cheaper available yesterday, tomorrow, etc. So there's a conversation. We have to have memory. We have to at least keep the context in mind to solve the problem, to a satisfactory extent. And I think the last one is there usually is the agents have goals. So for example, if you have a goal of writing a paper, and that's not the same thing as having a chat, right? So if I am telling an agent that, hey, I want to write a paper that is good enough for a workshop, and maybe I can give it some more information. I can say, well, here are papers I've written before, and here's probably an idea you can go off on. And then it takes that, and now it needs to figure out how to solve that, right? So now there's a lot of steps that are involved. There's a lot of tools it will have to use. If it's running experiments, then it needs to use tools to run the experiments. Along the way, it may have questions for me, right? So it's going to come and ask me, or I might ask it to do something different based on what I'm seeing. So then there's a long context conversation that happens. So I feel like those three dimensions are very important: goals, memory, and use of tools to distinguish an agent from just generic chatbot.
Okay. Let's turn for a moment to some of the concerns about large language models. First one is the well-known problem of hallucinating, meaning that they make up information or they provide misleading or weird off-topic responses. Lou, what causes those, and what are developers doing and researchers doing to correct that? I know this is a big piece of your research.
Yeah, absolutely. So given that we heard so much about like how those models are trained, I think our audience now knows very well they are actually learned to read those texts right? And then trying to memorize the patterns from there. And then you probably notice that they're not actually trained to do verification or trained to do access, the most recent information published online, say 5 minutes ago, whatever, the media is talking about, right? So they're not trained to do that. So in that sense, the models can be overconfident at what they already know or what they seem to know. Okay, so that's why you see their response sounds super confident and sometimes very authoritative, but actually they're fake, they're false information. There are a lot of effort being done to improve or resolve this problem. So I can give you some examples. One easy way to do it is kind of like a more post hoc, like fact checking, right? Once it's done, and then let's run some fact checker on it and tell me what is right, what is wrong. And other type of methods, including the ones that we've done in my group, is that we can leverage, more reliable sources like Wikipedia. We retrieve the information from there and use those information to answer the queries by the user. Other type of methods, including one thing that we work on, is that since the models tend to be overconfident at incorrect information, we can actually design calibration methods, such as like, I'm going to tell you that this is your answer, they're correct, and those are your answers that are incorrect. Now recalibrate yourself so that when you say something that is not very confident, you should tell us that. Or your confidence is so low, you should refuse to answer it. So that's in general a couple of type of methods people use to resolve this hallucination issue.
And what's the state of that? I mean, how, is there a kind of a way to get a sense of how much of a problem this has been, and is it getting better? Are the big AI companies having success with some of these, or are we still in the earlier stages of researching and developing these techniques?
I would say that there are a lot of effort put into this direction. Meanwhile, there are challenges that are like unresolved, and there's also new problems come up. So, in general, for example, for information that's really rare in their pre-trained data, they don't see them. When the models they are trained on their static data, and then they tend to be overconfident of what they believe, this is still like unresolved issue. And meanwhile, while those models become more powerful, they can also become more deceiving, right? So called here because I don't want to treat them as human, but they can be deceiving in a sense like they probably know what they know, but they don't want to tell you that. So there are new phenomenon, showing up just because they become more powerful and more capable of doing things that we used to think they cannot do.
Okay. There are a range of ethical issues around these tools. And I'll just list a few things. If you want to comment on them, go ahead, but I'm going to move along through this. One is the environmental impact. We've been covering the issue of how much energy the data centers that run these take. Another is, Mayank alluded to this, the accounting for the creators of the content that these are trained on. And then another is thinking about the labor that's involved in the training process, the human factor of the human feedback aspect of training. But I want to touch on one that's a little more directly relevant to each individual, each of us, and that is the privacy question. What should people be thinking about or be aware of in terms of their privacy when using these tools? And why don't you both take a crack at that? Mayank, why don't you start?
Yeah, so I think unfortunately, when we chat with these models, right, we cannot really guarantee, I would say, in a very strong sense, that the data will not be used in some way, back into the model. That being said, the different platforms have become more, at least more open, and they do allow you to opt out. They also delete session logs, after 30 days. And so there are measures that they are taking, so that is good news. But, researchers have found, for example, that, there is sensitive information that are not only being used in the model, but by applying, certain attack techniques, which have also been heavily researched, you can get the model to actually give you a password or sensitive information about someone. So there have been some very disturbing findings, on those things. And the only good news in that is that the companies are aware of it, and they are trying to make sure that the models are not being misused. But it's a difficult battle.
Yeah, agree on that. And also that the recent advances, or there's a general trend that we want those models to be more personalized. You probably noticed that OpenAI released a new feature, where they can, this feature is there, but they have been updating it. It's the memory mechanism for each user. So with the trend that all those models basically become more personalized, basically knowing me better, meaning that they have to memorize my data better. And then there are a lot of privacy concerns here, meaning, for example, what kind of data they're trying to memorize from me, and then what kind of information they're supposed to memorize, or what are the information is supposed to be, anonymized first and then handle them, and then how they're going to store them. Well, those data become part of their training data. So a lot of information is unclear in this phase. So this is something we need to be aware of when we use them, as well as develop a new technique to train such kind of versions of the model.
Okay, and we'll get to audience questions in just a moment. One last one from me for both of you, starting with you, Lou. What are things you would advise people not to try to use these AI chatbots for?
That's a really good question. So I can probably argue that from my personal, perspective, because everyone's using them for very different, purposes. For one is that I would suggest people not to send sensitive data to those services, because so far we still don't know how those things work, especially with those, closed model and services. The second thing is that I wouldn't suggest people to ask for, high stake advices from the model, like medical suggestion, like legal suggestion, if you believe those are high stake decisions you want to make. All right. So you want to be careful about what you're actually asking them, and then try to be, critical when they return those questions, because those models can sound really persuasive.
Maya, what do you think?
Yeah, the only thing I would add to that is that whenever the model gives you a number, or something that it claims is from a source, uh, just click on it gives you a link, and you should click on the link, to verify, because it does on occasion make up the number, or it claims that the source is saying something that it does not. So it's good to get started, but verify. What I would say is, just it's very important to verify. So you can ask it initially, but then just verify. Just don't go with exactly what it's telling you, especially if your career or an important presentation or something you're doing depends on that.
Okay. All right, let's take a look at some of these many good questions flowing in. One that just popped in that I think is particularly helpful here is, as an amateur user, how do we know if AI is hallucinating or has checked its facts?
I guess I can start. So it's unfortunate we don't know that. And I don't want to sound so, pessimistic. We already mentioned that, for some of those AI models, when you ask for a question which require, a lot of, like, say, facts, they sometimes give you the URL to tell you where, they draw this conclusion, or which this piece of evidence they draw. You can click on those. However, the downside is, like, the effort is on the user to check whether this is correct or not. And meanwhile, I'm pretty sure that all those companies, and including, researchers from academia, were working really hard to develop more effective tools to help us to, reduce those hallucination issue.
Mayank, do you want to add to that?
No, I totally agree. I think the best thing that you can do is to click on the source. You have to go back to the source, and that's the only way to make sure. But they do make it easier by citing the sources in a lot of cases. So it's just a click away. It is some added effort, but I think it still reduces the effort if you had to look up all the sources and compile, and most of the time it will be correct. It's just that in a few cases it will not be correct, so it's always good to click on the link and just make sure. It takes an extra minute, no more than that usually.
Okay, we have a question really about guardrails. what constraints and rules have various models imposed on themselves? What will they not agree to do or answer? Mayank, when do you start?
Yeah, so this is a very big topic actually in academia and in industry. And so there are guardrails around almost all the major models now. So if you ask it for, just very dangerous things, which are clearly illegal, uh, you'll find it difficult to get a response out of them. They will say that, okay, that is not something I can help you with. And usually, now, unfortunately, it is not foolproof. So there are ways to break the guardrails. And in fact, this is something called jailbreaking. So you can jailbreak the models. I mean, it takes some sophistication to do that. I mean, think of it like a cyber attack, in a way, right? You're attacking the model just like you might attack a web server with a denial of service attack. But you need to, if you come at it with a malevolent intent and you have the sophistication, you might be able to do that. But the companies are getting better at preventing that kind of behavior. And if you ask it for something really dangerous, and the reason why I'm being a little bit vague is because I don't want to give specific ideas even, over here. But anything that I would argue that a normal human being, it would raise red flags, right? It would be like, why is this person asking me this question? I think the models would refuse to do that, at least at first prompt.
Lou, do you have something to add to that, or?
Yeah, I think that's very good answer here. And in general, I would tell folks that, there's a lot of effort going on in terms of AI safety. And then during their training, there is a special phase, which is the last part of learning from the human preference part, where the models will be explicitly taught to perform, safely. However, it's not perfect. There are a lot of rules, constraints encoded in the training process. But it's an active research area, and then everyone, cares about it.
Okay. We have several questions that are in the realm of fears or concerns. One is, can the systems access your personal information on your computer? And I think this becomes a more acute issue when we start talking about AI agents. Lou, what's your sense of that?
So depending on the context, there are AI agents, we call them more like computer system agents, where they're designed to have access to your computer because they're here to serve, right? So in that sense, they will be given access to, say, your file, to perform tasks like, please clean my disk, right? Get rid of those, useless files I haven't touched on for years, right? So they will have access to your data. But the idea is that they should do this or have access to things that only when they are explicitly given access to. So that's how the computers are designed to give the right access, control to the users. But like we have discussed, there will be safety concerns, right? Whether they perform things as what they intend to do or they are supposed to do. And those are, up for debate at this point.
Okay. Mike, anything to add to that?
No, I think that's a great answer.
Okay. Another question about fears is comes from an educator, it seems, talking about how students in particular are concerned looking in various ways beyond even just LLMs to other AI systems, being able to perform a lot of the work that they're learning to do. So as educators, but it also, this is useful for everybody, how do you address this sort of AI anxiety about what it means for work in the future?
I mean, I can begin. Unfortunately, I wish there was more anxiety in the classroom. I think what I am seeing is an overuse of ChatGPT, often by many students, and we are not able to police it. I mean, I tried that last fall in a graduate class, and what we learned was that the students are using it for all kinds of things, for writing homework assignments, for writing code. And I know there are some questions also on what the practical use cases are, of this. And one of them really is programming. You can now write entire programs, very complex programs. You don't need a software engineer anymore to actually write programs. So students are using it for that. And rather than police it, what I figured was that they should just acknowledge it. They should say that, hey, we are using ChatGPT, I'm acknowledging the use of it, I'm responsible for its outputs. I cannot blame ChatGPT if I get a bad grade on the homework. All of that being said, I think that if there's an overuse and overdependence on this tool, then it's going to be difficult to get our students to learn fundamental knowledge. And I think that relates to the anxiety. If you're an art student and suddenly you're using AI, or others are using AI to do what would have taken years for you to learn foundationally, and if those skills degrade, right? Because many people stop using those foundational skills and they just rely on AI for everything. I think we'll have a big social problem. I think a lot of skills will get eroded, including basic reading and writing. And it's really something we have to think about for our students. I am very concerned about it. Honestly, I think our students are not reading and writing anymore in the same way that they used to.
Lou, what's your experience?
Those are great insights shared by Mayank. So in fact, that the University of Michigan is the university that's I think it's the earliest one that we make ChatGPT available to all our students, staff, and faculty, because we think that it's already there. They should be allowed to use them to learn better. All right. So of course, the focus is on how they can learn better, right? So like Mike said, they might become, lazy in a sense, like I don't want to write anymore. I don't want to read anymore. It's right there, right? So we put a lot of efforts into how we can use it better for teaching. So for example, one application we have is building a customized version for every course, right? So for the subjects we're teaching and then trying to understand what students want to ask. So we have been doing that. I think it's very well received and then still developing. But I agree that this is actually produce a possibility where students may not learn the fundamental things. So we have to think about how to design the exams or quizzes or tests to make sure that they still acquire the right knowledge and skills. But meanwhile, I also want to be more optimistic in the sense that those models definitely provide easy ways for students to learn faster. I see it as a way to democratize education, because in the past, maybe only the students in the better social economic status can hire tutor, right, to learn better. But now we probably have one way to make it as a more demographic, more democratized tool that everyone can use it.
Okay. A different kind of, on the other kind of end of the spectrum, in a sense, for people who aren't in academia or in education, who aren't necessarily in knowledge work or creative work, what are the reasons to use it? Why would some average person on in their home or at work, what would they use these for? I mean, there are obvious cases of like I was mentioning, knowledge work and creative work, where there's a fear on the one hand, but these are also tools you might be able to use, and we can understand how these would be useful. But for someone who's not in one of those areas, what are the kind of everyday uses of these?
Yeah, I can think of a couple of use cases. So, one of them is like, let's say you're a business owner and you need to build a website, right? I mean, think about what that would entail, right? Once upon a time, not too long ago, I mean, you would have to hire someone or you would have to learn how to build it yourself. Well, now you can build really fancy websites, just using some of these tools. You don't have to become a website designer even. If you like, you can really implement your vision, instead of learning how to write, very complicated, web tools, or learning how to use web tools. So it's like, okay, I have a vision, I want to build a website, and now I can use tools like ChatGPT and Claude and Cursor AI and a bunch of tools out there that really get you up and started, writing code or generating code for you, so that you are doing the designing. You are responsible for the high level vision. You are not learning a programming language. So I think that is, like if you're looking to build your own website, if you're looking to build, marketing, newsletters, like things that you want to put on social media, you're not quite sure how to express your message, you want it to become more succinct, you want to learn more, about how to do your taxes, things like that. It really is a very powerful tool for just getting you from like 1 to 75 and then you have to do a little bit more work to get all the way to 90. But you're not starting from scratch anymore, and you can save a lot of money, by not, unfortunately, by not hiring a human, right? But that's kind of what technology does, which is that instead of spending $100,000 or $80,000, like hiring someone to design a logo for you or building a website for you, you're in control of that, and you can build something in just a few $100, quite possibly. That being said, will it be as good as someone who is like really in the top 1% of their fields or even in the top 10% of the fields? Perhaps not, right? We have to see where the technology goes, but it certainly will allow you to be better than average at a much lower cost. And that, I think, is very powerful. I mean, it opens everything up to the rest of the world. And so you're not restricted to hiring people who are knowledge workers. You can take control of your own vision. And I do think that is very powerful for a lot of people out there who are not in knowledge work.
Lou, anything to add to that?
I think those are great answers already. I just like some personal experience with those model. I think that when I learn some new concept, I want to quickly know what's related things about it. I tend to use them, but with some critical thinking behind it, right? On other times, like when I go to a new area, I don't know where to visit. I also use them. Tell me, what's the places I should see, right? Give me an itinerary. I think they did a reasonable job, like to help me to quickly know something I don't know before.
And can I just add real quickly, because that just sparked something. So I recently met someone who was in the UK, and she went to the UK, and this is like an older individual. She's not a technophile or not a technologist. This is someone who went to the UK. She found herself in the Hyde Park area, and she had an afternoon to spare. So she literally went to ChatGPT, and she told me the story personally, and it created an entire itinerary and like how she should go to all the different places and what's the history behind them and so on. She's like, well, it was almost like a tour guide. I got my afternoon's worth of sightseeing in Hyde Park, and I didn't have to spend an hour researching on Google, like where I should go and what I should see and all of that. So a small but telling application, how it can make everything easier.
Great. Going in a different angle, different direction here. I briefly mentioned in sort of the list of concerns environmental impact, and there's a question about that, quantifying that if there is. So the example given is, if I ask ChatGPT for a cornbread recipe, what is the electrical cost? Do you guys have a sense of metrics at this point on energy use?
Yeah, I can quickly point to a couple of sources where I've seen this. Of course, we don't know everything because the models are proprietary, and so we don't, especially for the newer ones, we don't know all the details. But the estimates are that for training something like GPT-3 or the early versions, which came out in sort of the 2023 to 24 period, it costs more than basically the electric cost of that would use to power 100 to 150 US homes for an entire year to train something like GPT-3 or 4. For 4, it's much higher. For 3, that is a more likely estimate. But think hundreds, maybe thousands of US homes, the electric use for all of those homes for a year, if you add those up, that's kind of the cost it takes to train the model. Now, when we use the model, it is also expensive in terms of energy. So the estimates range from the amount of energy that it takes to charge an entire smartphone. That's kind of what it would take to prompt one of these models. So when you ask a question to these models and they give you back an answer, on average, it is almost like every time you ask a question, it's like you're charging your phone from 0 to 100, roughly of that order. That sounds like a lot. It is a lot. There are a lot of concerns, but the good news is it's getting more efficient. And like all technology, I think it will go down to something a lot more efficient in the very near future because it costs money and the companies are incentivized to reduce that cost as much as possible.
Lou, have you seen any numbers lately, or does that fit with your understanding?
Yeah, so the reason is really we don't know so much about those priority models, right? So they're hiding those details, but the rumor, okay, so that's training those larger models like GPT-4 level, or maybe even the largest models, given by Meta, they're called Llama. Those models probably will be thousands of, tens of carbon emission, which is a lot. That's definitely a daunting number. So those are for training. So the inference will be much, lighter than that. And I agree that there are a lot of like efficiency, techniques are being developed, how to do this, better. One method is kind of like, dividing one giant model into a couple of smaller ones. And then when you send a query, it's only got to route it to one smaller one. So this is one technique to make them more efficient.
Okay. Let's see here. There's a question about kind of the industry aspect of this. I think there's a question about all the money that's going into the development of these systems. Companies are spending billions on developing these models and will need to recover that at some point. So the question is whether any of these applications are going to be viable. Depends on the cost of accessing these. So what's that balance between the huge investment and what these companies are looking to make from this and affordability and accessibility of using the services that the companies offer?
I mean, I can just offer like one response to that. So I think yes, they are spending very aggressively, and like so many other startups. I mean, technically, OpenAI is a startup, right? It's a private company. It builds itself as a startup, and it's they make heavy losses in the beginning, and this is no different from many other companies like Uber or even Google, Facebook. All of those companies in the beginning, Amazon, right? They all made heavy losses, but ultimately they became profit-making machines. So the hope always with these companies is that eventually, yes, they will recover and their business model will reach a point where they will start making a lot of profits, like an earlier generation of startups were able to do and went into the public markets to do so. Some of them will fizzle and fail, right? This is the norm with any technology startup. Not everyone will succeed. So some will get bought out, some will fail, some will run out of money. We're seeing that already in some sectors of the AI space. But then in terms of how will they make the money, ChatGPT is not completely free, right? For the pro tier, and when you use it for actual applications, you do have to pay money. There is a paid tier, right? So they are making money. They are not a non-revenue generating a company by any means. And they right now a lot of their money is spent on training these models, on developing the next new model. I mean, a point will come when they will stop doing that or doing that as aggressively as they are doing now. So it will cost less money to train their next model, but the revenue will continue. And if they are market dominant, then they will be able to charge more. And they're also coming up with new products and services. So OpenAI, speaking of agentic applications, OpenAI recently said that it's almost ready or will soon be ready to launch a $20,000 a year model that would be like a software engineer. So this is just one example. So software engineer costs you $200,000, $300,000, depending on where the software engineer is, right? If that gets down to like $20,000, there are lots of questions we have to ask about what happens to the economy. But in terms of sheer productivity, that's a 10x boost in productivity, and the company makes money while doing it, right? So they do have viable business models. It's just that right now the field is in such a nascent stage still that they need to build the next big model and they need to capture market share. And in that, they are no different than an earlier generation of startups.
Yeah, Lou, what's your take on how accessible this technology is likely to remain or to be in terms of cost accessibility for people?
Yeah, so I guess that I bet on the free market and the competition, meaning that if we do still have a couple of players that in this area where all of them are building stronger models, that's probably the hope that to keep the costs down because they are motivated to make those models more efficient, like the one we just talked about, right? So I think I'm more optimistic that all those companies they are definitely invest big in model training, and now they're also invest a lot in agentic system, like Mayank just said, right? As well as other type of, algorithms beyond the training. So we call them more inference time, meaning that now you have this model, how you can use them in the most effective way. So I think that the cost for the same type of model probably will go down quickly. And meanwhile, we will expect more powerful model will be trained. So that will be the two directions going to go. Yeah.
Okay, another question we have is about these models being used, or AI being used in search engines, and how do you know if your query is being processed by an AI, and hence whether the concerns about the accuracy and veracity of the answers you're getting.
So I can start with that. So for what I know from the popular search engines like a Google or Bing, they would tell you that this answer is generated by a AI. So we definitely need to pay attention to that. And clearly, those answers, they suffer from the problems we just talked about, like, say hallucination or potential bias, right? Misleading, right? So we need to be careful of that. I think this should be the company's responsibility to declare those are AI generation and those are the authentic content from the website, right? So it shouldn't be the user's responsibility to check which one is which, right? And meanwhile, like we just mentioned, right? So those AI generation, they do give you the link. Make sure that if there's anything looks suspicious, you should definitely click on that and check by yourself.
Anything to add to that, Mayank?
No, I think that's they do declare it that this was generated by generative AI, and that's a great thing. And at the same time, the search engines also give you the traditional results, which is the list of web pages. So you have to make your decision whether to go with the generative AI or not, but you should always click on the link if you're relying on it.
Okay, one last quick question from me for each of you. If you had a child who was a middle school student, how would you advise them to use these tools? Start with you, Lou.
My child is younger than that. I'm still thinking about a problem. So I would say that I think they're still in the age of trying to learn a lot of things about the world, trying to, reason what's happening. And then this also very important phase that they build a good relation with the technique. And then they need to learn how to use them to make them stronger. So in such a sense, I would advise them to use them carefully for sure, right? And then make sure that to still have the critical thinking and to think about whether this is possibly right and wrong. And I would also encourage them to learn those techniques. Because only when you know how they work, how to build them, then you can, address all those issues they may have.
Mayank, real quick, how about you?
Yeah, I mean, I would not turn them away from the technology, but I would also be a little bit more old-fashioned, so and I think Gen Z, right, what we're seeing is they are really looking for that. Some of them have these days where they turn away from their phones altogether. There's students who are coming and saying that they have gotten back into like physical books. I mean, I've heard that so much now, that a physical book is really something that people have started to treasure again. So I would encourage all of those things, and like more human contact, more conversations, more, just the things that make us more human. So I would emphasize that more. I would be like, these are great tools. You can use them for all kinds of things, but let's also focus very strongly on what makes us human. And I think that needs to happen from a very early age. Yeah.
Great. Well, thank you both for participating in this. It's been really enlightening for me, and I hope for the audience. Handing it back to you, Beth.
Yeah, thank you. That was a fascinating hour. And just thank you, all of you. It was fascinating. So many questions. We will plan to do another webinar down the road so we can answer everyone's questions. Simply too many for one webinar. Just a reminder that we are a nonprofit, The Conversation, and we appreciate and are so grateful for any support that you may choose to give to us. If you can afford it. And if not, continue reading us. We really appreciate it. We'll drop a link in the chat. Thank you everyone so much for such a fascinating and important conversation.